Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to start by taking a look at Lab 1, Exercise 2, and beginning in Task 1. It essentially tasks us with importing code that somebody in Microsoft already wrote that will import the recipe data from a text file. All right. Now, ideally, I'd love to rewrite this entire class that we're asked to just drag and drop into our project. I'd love to rewrite it from scratch on camera. However, I tried that and then I threw away those videos because frankly, it was a little bit boring. It was just 50 minutes of me typing and making spelling mistakes. And there wasn't a lot of insight to be gained from just watching me type, okay? So I started over and I decided to take a different tact. Now, don't get me wrong. I still firmly believe that we should take time and really understand how this data access class that we're asked to import works. After all, there's a strong chance at some point that you're going to need to write a class like this on your own to retrieve data from a text file or from a database, from an online web service, or from some API. So we're going to devote a video or two, maybe three, to understanding both the sample data source that comes out of the box and creates the default data inside the grid app template, as well as the recipe data source that we're asked now to drag and drop into our project. So what I want to do to start really piecing all these things together is to look at the grouped items page.xaml. And here I want to focus on this page.resources section. We've just glanced by this a couple of times. I said that it had something to do with data binding, and then later on I said something about the fact that it could be used for adding paged scoped resources, so you can add styles and templates here. But if you do so, it would limit the scope, or rather their usage, to just this page, and we thought maybe it'd be a better idea to keep those separated in their own file and then bring them into the app.xaml. All right, well, at any rate, whenever you build a grid app using the template will wire up the data binding from a set of sample data to our XAML page through the use of this collection view source object. And if you look at Microsoft's documentation for this collection view source, you're going to read that it really has two purposes. The first one is that it acts as a proxy, a go-between, between the collection classes, for example, the data that's in the view model, and the user interface elements that we see here on our XAML page. And then secondly, it adds grouping support. And as we use it in the grouped items page, it's performing both of those tasks for us. So what I want to do is pick apart the attributes of the collection view source so that we really understand it and focus, first of all, on the data binding features. The most important attribute from a data binding perspective is the source attribute set here. And you can see that it's dynamically bound using this binding element syntax. Is dynamically bound to this idea of groups. Now, where's groups coming from? I think I hinted at this before. If you pop up to the page's declaration, you get a little bit of a hint here. We have this attribute called data context. So when we think about data on this page, what's the context? Where do we look for the data? We look for it in the default view model. All right. So now let's move to the partial class definition for this page. And here we see in the load state, so as the page is loading, where the default view model is setting this key called groups equal to some data. And that data is retrieved from this class that we'll look at later in this lesson, the SampleDataSource. We call a getGroups, and it yanks back all the groups and the items that are associated with them. And then it sticks them into this default view model keyed into this key of groups, which we then key into here with our collection view source, and then we bind to it down here in our grid view using this item source grouped item source that matches the name of our collection view source. Okay, so that's how it's all wired up. All right, so this default view model is a little bit mysterious. Let's go ahead and pick this apart. I'm going to highlight it and then right click and select go to definition. And when I do that, I notice that it's defined in our layout aware page. So every one of our pages in our app will have the ability to access this default view model and use it on its given page, right? And as it turns out, the default view model is designed to be a simple view model. We can see here from the explanation, which simply means that it's an easy way to pass data between the code behind for the XAML page and the XAML page itself. So whenever you see these words together, view, model, think a special model of data, a special collection of data, a special representation or data structure that's to be used exclusively by the view. And in this case, the view is just code word for the XAML page that defines the layout for the app's user interface. Okay? So the default view model, as we see it here defined, is a special kind of generic collection of type IObservable map of string and object. All right, if you were to look at this in Microsoft's documentation, it's actually defined as IObservable map of K and V. K in this case is generically set to string. V is generically set to object. The letter K stands for key, and the letter V stands for value. So a key value association. So if you recall in our C# Fundamentals course, we looked at generic lists, so list of T. And this is similar, except that it has some superpowers. And so let's go through a few of its superpowers. First superpower is the power of interface. This is not a collection, but it enforces concrete collections, like our default view model, to implement certain functionality. An interface is another form of the idea of establishing a contract, sort of like we learned about schemas a couple lessons ago, schemas in XML. Now, as a contract, it says that a class that implements this interface promises to support certain properties and methods and such. So there are two parties in a contract. The first party is the class that implements the contract. So, for example, the classes that promise to abide by the rules of the contract. I promise to implement the properties and methods as outlined in the contract. And then the second party of the contract is the consumer of those classes. They say, I only work with objects that support this contract, this interface. So at a minimum, the consumer can be sure that any object that it gets passed to it, no matter what type it is, at the very least will support certain properties and methods outlined in the contract that it knows how to work with, okay? So in this case, the contract IObservable map of K and V forces any class that chooses to implement this interface to support two things. First of all, to support change notification, and then secondly, to support mappings of a key to a value. So let's start with that second superpower, the mapping, or the power of being a map with a key and a value. Another word for a map is a dictionary, and so you'll see a dictionary of K and V defined in the .NET framework, all right? So you can see that there's a definition for two types here, which we've already called out. The key will be a string, and the value will be an object. A map or dictionary allows lookups. So you search for a given key to find an associated value. So in this case, our default view model sets a generic key as a string and then a generic value as an object. So given a name like groups, for example, give me back an object, like this object graph of sample groups and sample items. Now in this simple example, we only need one set of data, but if this user interface were more complex, there might be other entries in this map or dictionary called default view model. But as it stands, our default view model only needs a single entry because we're just displaying related groups and items, as you can see here. Groups, items, okay? So then the third superpower of the IObservable map of K and V is change notification. Let's get back there. All right, so in a nutshell, if anything changes in this collection, the collection promises to broadcast a message to any user interface elements that might be watching, or rather observing it, thus the name observable, okay? Hey, something changed inside of me, better update yourselves. That's what it's basically saying, all right? So if we look at how the default view model is actually used in our code right here, we can see these superpowers at work. The default view model allows us to associate a collection of groups and items to this string called groups. Now in our case, we're only using the single item in the dictionary, but then on the but like I said earlier, you could have multiple of these groups and all sorts of other different data that's then used by the XAML page. Now on this side then, in the XAML page, we look for a collection of data associated with the string groups, and then we bind to that collection in our user interface elements, in this case the grid view. All right, so we're going to talk about another observable collection, the observable collection of T, in an upcoming lesson. It shares many of the superpowers of the iObservable map, but it more closely resembles the list of T that we learned about in the fundamental series. Again, we'll talk about this as well as change notification and all that it implies in an upcoming lesson. Okay, so the default view model is of type iObservable map. We're setting a key of groups equal to a collection that's returned from the SampleDataSource getGroups method. Let's see the definition for the SampleDataSource. So I'm going to right click and select go to definition. And here it opens up this SampleDataSource.cs file. And ultimately, starting in the next lesson, we're going to replace this file, and we're going to replace it with that file that we're going to import that's already been written by somebody at Microsoft. So it's imperative that we understand what's going on here so that we can recreate this if we ever need to in our own apps. All right. So first of all, there are 3 data types that are created in this file. So let me just use the code outlining feature to kind of make this a little bit more obvious, and then I'll roll this one up too. There's actually 4. All right. So there is a sample data group and a sample data item, and they both derive from sample data common. All right, so if we take a look at our grouped items page, one more time, group items. And so that's where these are defined. Group items, all right? And they both share some things in common. They both are derived from sample data common. Let's go ahead and expand that. And so here's a constructor that allows us to pass in certain values to get the object into a valid state right off the bat. But here there are just some common attributes: unique ID, title, subtitle, description, and then an image path and the image itself. And so both groups and individual items will need to support all of these attributes in order to fully flesh out the template that we see in the designer. Now we'll talk more about the sample data common a little bit later when we talk about change notification. But for now, we see what they have in common. What makes these 2 classes then different? Well, let's start with the sample data item. And you can see that it defines 2 additional attributes: content and group. And we can see how these are manifested in the item detail page in particular. The content is the large body of text, and the group allows us to navigate from the item back to the group, its parent, right? Now the sample data group is a bit more complex. It exposes 2 collections, a list of its child items and another list of child items called top items. So here is, scroll down through this, items and top items. All right, so what's the difference between the 2? Items will contain all the items, as it implies, but top items, you'll actually see the justification for this in line number 143 here. It says it provides a subset of the full items collection to bind to from a grouped items page for 2 reasons. The grid view will not virtualize large item collections, and it improves the user experience when browsing through groups with a large number of items. So a maximum of 12 items are displayed because it results in a grid, a filled grid columns, whether there are 1, 2, 3, 4, or 6 rows displayed. So the top items will be used as a subset of all a given group's items to be displayed on the group items page, depending on the screen resolution. So to see how this works, what we can do is use a special feature of Visual Studio called the simulator. And so next to the run local machine, if you were to use the little down arrow next to it and select the simulator will help us to visualize different resolutions and screen orientations. And it'll also allow us to do things like simulate the touch gestures for the app. So here, let's go ahead now and run it in the simulator, and you can see that instead of running full screen, Visual Studio will launch the simulator in its own window. And you can kind of think of the simulator as a virtual machine inside of your physical machine. So it has a start screen like we see here. It can even launch another instance of Visual Studio. I wouldn't recommend it, but I find it more convenient to execute your app when you're debugging it rather than in full page mode, to actually use the simulator, because you never leave the IDE on the desktop and then have to switch back to it. You can always just get back to it just by clicking behind the simulator, and it shows up here in the start bar at the bottom. And like I said before, it makes it easy to simulate some of the touch events like pinch, zoom, touch mode, rotation, touch mode, and so forth. Okay, and so what we can do is use this little change resolution button off to the right hand side, and we can see now it's set up for a 10.5 inch display at a resolution of 1366 by 768. But we could change and see how that would affect the layout if we were to go to to simulate a larger screen, a 23-inch screen that's 1920 by 1080. Now, I'm not running that resolution, but it will resize the contents of the page to look as if we were running it at that resolution on a screen size that large. So you can see the simulator doesn't change sizes, but everything inside of it will now appear smaller. And you can see as a result, we can see more information than we could had we used the smaller screen size. We can also do things like rotate the device and see how our app would look this way. But again, the top items collection is intended so that if we were using the app in a smaller resolution, you wouldn't have to continue to scroll to the right to see every single item, perhaps 50 or 100 items that are associated with a given group. Instead, it limits the number of items in a group to 12 for the purpose of this display. Then if you wanted to see additional items, you could go to the group header, click on it, and you could see then all items associated with a given group, and then scroll off to the right hand side. So this is meant to be to simulate like a hub experience. You'll see that word used occasionally in association with this style of user interface. Alright, so let's go ahead and stop the simulator for now, just by hitting the stop button in Visual Studio. So you can see here that as I was looking at this little explanation of what the top items is, that it's actually embedded in this items collection changed event. And so what this will do is evaluate how the collection has changed. Have we added new items to the collection? Have we moved an item from position 13 to position number 3? Have we removed an item from the collection? Have we replaced an item in the collection, or have we completely reset the collection? Depending on the change that was made to the underlying collection of items that are associated with the group, we're going to modify which ones fit into that top 12 category. So all of that logic is inside of this items collection changed event handler. But the real question is, we've been looking at the sample data items and sample data group declarations, but where are all of the new instances of these items actually created? Well, we're back now to this SampleDataSource class. Let's expand that out. And you can see a number of collections like this observable collection of T, or rather observable collection of sample group data group called all groups. Then there's also this get groups, which returns, oddly enough, only all groups. All right, and that's what's being called on our grouped items page.xaml.cs. It takes this navigation parameter, which at the very outset, as our application is launched, it will pass a navigation parameter, this page state, or rather this navigation parameter here in the load state. So the frame will pass this into the page, and then we can do something with it like filter data or specify a single item to display. In this case, it's set to all groups, kind of hardwired that way, but only to give us a template so that we could change it for our own purposes. And furthermore, if we look at the sample data source, it's kind of hardwired so that that value that you pass into get groups has to be all groups. If not, it throws an exception. Only all groups is supported for a collection of groups. We could expand this out and create different versions of this, like top 10 or top 5 or top 6 or something like that. But by default, it's just all groups, and it returns that for the call. So that's where we get the return, but we still haven't answered the question, what populates all groups? Well, if you scroll down here, you see the constructor for this class, SampleDataSource. And inside this constructor, anytime we create a new instance of SampleDataSource, it will create a number of groups and then associate individual items with the group. So here's an item, here's an item, here's an item, another item associated with our group number 1. And then it adds those to the all groups collection. And it keeps doing that with group number 2 and all of its items, group number 3 and all of its items, and so on until it's added all the data. So this is all hard-coded directly into our application. Now, I generally recommend in a real application that you never take this approach, because if you ever have to change something, it will be difficult. You'll have to redeploy your entire app. Instead, you could just switch out just the data file that's associated with the app, and it would be easier to edit in a text editor and things of that nature, okay? So let's put this in perspective. This is sample data using a series of related objects representing the generic notion of groups and items. If we were building an app that needed a different ontology, a different hierarchy of objects, clearly this wouldn't work, but it does provide a great template that we can use to create our own in the future. Furthermore, let's suppose that we wanted to save our data outside of the code. We didn't want to hardwire it like they've done here with the sample data. Obviously, we wouldn't want to do that. We'd want to either pull from a file or a database or some online service or online API that can serve us data that we would then display in our app. We would likely do any data access doing something similar to what they've done here in the constructor of the data source class. We would just write the logic to grab the data from an external source. And for the purpose of this lab, that's exactly the approach that we're going to take. We're going to use a data file, a simple text file that contains definitions for groups of recipes and then individual recipe items. Yeah, we're going to need to make some modifications to the templates here and there, but a lot of the hard work has already been done for us. And by hard work, I mean that somebody has already given us a pattern to follow. We'll just need to swap out with our own implementation of group and item, and we'll need to read the data from a file and then hydrate these groups and items instead of just hard coding them like we've done here. All right. So I tell you what, that's enough for now. Hopefully you can see how all these pieces work together in order to give us the end result that we see so far with all the sample data and all the relationships between the groups and the items and how they're then displayed onto our XAML page as we start up the app. All right, so in the next lesson, I want to quickly address the design time support. And we're just going to go through this really quickly, but I want to answer a fundamental question. How is it that we see this data at design time? I mean, yeah, I expect to see it at runtime because that's when this is happening, right? But at design time, we're not executing code and event handlers. So how is it that all this data is being displayed? All right, we're going to answer that in the next lesson. We'll see you there. Thank you.